Hello students. So today we are going to continue some of the problems which are based on universal law of gravitation. So under that first question is the gravitational force between two objects is 49 Newton. That means if you have considered any two objects, for example this is an object A I'll consider and another one object B. Okay, the gravitational force between these two objects, that is F value what we are having, that is 49 Newton. Okay, how much distance between these two objects can be decreased? That means the distance between these two objects, you know, it is D. This distance I can reduce so that the force between them will become double. Since the force here it is 49 Newton, you know F is equals to G m1 m2 divided by D square. Am I correct? So you know this force is directly proportional to the mass of those objects, mass of object A and mass of object B, but force is inversely proportional to the distance between them. If I reduce the distance, how much if I reduce the distance? That I don't know. While thinking you will say that if I reduce, this is half. By half if I have reduced the distance, means the force will become double. Isn't it? Because these two are inversely proportional. If this is doubled, means distance is doubled, means force will become half of that, half of the distance value. So here what is the question? How much distance between the two objects can be reduced so that the force between them will become double? So I want the force to become double, that is 49 Newton should become double, means 49 into 2 means 98 Newton I want to take, so that how much will be the distance I should reduce? So that is the question. You have to prove it. In the mouth you can say that you have to reduce by half so that the force will become double, but you have to prove it by the formulas. Okay, for this condition let me take F is equals to formula G m1 m2 divided by D square. Okay, let me substitute the value. Force is 49 Newton. If it is not decreased, first it was, so 49 Newton m1 m2 divided by D square. Let me take this as equation number 1. So next what I am considering, same formula. If I reduce this, isn't it? I want to reduce the distance. I want to reduce the distance, that I am going to consider reduced distance as x. Okay, x is the reduced distance. X I am going to consider as a reduced distance, and F, when I reduce this distance, what will be the F will become? F will be equals to 2 times of F, isn't it? F will become double. If I reduce the distance, F want to become double. So now let me substitute 2F is equals to G m1 m2 divided by D square. In place of D square, I am going to write it as x square. So what is 2F? 2 into 49, it is nothing but 98 is equals to G m1 m2 divided by x square. Okay, let me take this as equation number 2. I want this x value. How much will be x value will be reduced? That is the reduced distance. To know that, I am going to divide equation 1 by 2. So divide 1 divided by 2. Okay, 1 divided by 2 if we are divided. So here I have divided it. If I divided it, I am getting G m1 m2 by D square. This when goes to numerator, it becomes x square. That is cross multiply x square by G m1 m2. So these two will get cancelled. So what is the remaining here? X square divided by D square is equals to 49 by 98. 49 by 98 means 49 ones are 49 twos are, isn't it? So x square by D square is equals to 1 by 2. So now what the value of x will become now? So let me do cross multiply this. 2x square equals to D square. D square into 1 is nothing but D square. 2x square is equals to D square. So x square is equals to D square by 2. Now x will become square root of d square by 2. Square root of d square means square root and this will cancel. So you will get x equals to d divided by root 2. So what is the x? How much will I should reduce the distance? I should reduce the distance by 1 divided by root 2. So how much distance I should reduce between the two objects is 1 divided by root 2. Okay, this is the answer. Second question is, two bodies A and B having masses 2 kg and 4 kg. So for example, two bodies I'll consider. One I'll consider MA, that is mass of object A, and mass of object B, MB, I'll consider. Their mass of object A is 2 kg and mass of object B is 4 kg and are separated by a 2 meter distance. So the distance between these two objects is 2 meter. Okay, where should a body of mass 1 kg placed so that the gravitational force on this body due to A and B is 0? That means, where should I place a body C? That is a body C of mass 1 kg. I am going to consider it as MC. Okay, where should I place? That is what distance? This total 2 meter distance from A to B. In between that, at what distance should I place the third object, that is mass with 1 kg, so that the gravitational force between A and B will become 0. Okay, so that means what is the distance between them? The condition given here is, if we place this object in between that it's some distance, then the gravitational force between A and B will become 0. Okay, to find out that, first let us consider the gravitational force between A and C, object A and C, then object B and C. So for object A and C, I am going to consider as FAC. Okay, gravitational force between these two objects. Formula G m1 m2 divided by d square. Okay, G m1 m2 means G ma mc. Ma value how much is given? Mass of that object 2 kg. So 2 into m2 is nothing but C, that is 1 kg. 1 divided by d square. Okay, so now FAC will become is equals to 2 into G, 2 into capital letter G by d square. Take this as equation number 1 here. Now this is the force or the gravitational force between object A and object C. Now we want between object C and object B. So that is when I am going to consider FBC is equals to GMB MC divided by d square. Okay, so since, see here, the distance between MA and MC, that is I am going to have considered as D itself, isn't it? The distance we have considered is D itself. This distance A and B, if you consider, that distance is 2 meter. If the distance between A and C is D, if I consider, then what is the distance between C and B? Total distance is 2 meter. 2 meter minus d, that is 2 minus d will become the distance between C and B. Okay, I am clear, no? So distance between A and B is 2 meter. That means the distance between A and C is d we have considered. Then what is the distance between C and B? The distance between C and B is 2 meter minus d, that is 2 minus d here. So G, mass of object B is 4 into mass of object C is 1 divided by distance. How much here we are consider? 2 minus d whole square, because it is square is there. Now let me simplify it. 4g divided by 2 minus d whole square. Okay, let me take this as equation number 2 here. Now since we know C, the gravitational force in between, that is between A and B is 0 means, then FAC is equals to FBC. Now let me substitute FAC value, that is 2g divided by d square is equals to 4g divided by 2 minus d whole square. Okay, so G and G get cancelled. So here directly I can simplify 2 ones are 2 twos are. Okay. So next, what is the remaining? 1 divided by D square equals to 2 divided by 2 minus D whole square. Let me substitute. So cross multiply this. These two are 2 minus D whole square is equals to 2D square. Okay. So now 2 minus D whole square is there. So let me take this square to this side. It becomes square root 2 minus D is equals. When this root 2 comes here, it becomes square root of 2D square. Okay. This D square and this root will cancel. So 2 minus D will become. For 2, root 2 will be remaining. For D square and root cancel. So it becomes D here. So since here minus D is there, here root 2D is there. D and D I'll take one side. So it becomes 2 is equals to root 2D minus D. When it comes here, it becomes plus D. Now here I can take 2 is equals to D is common in both the side, here also. D I'll take outside. If I take D outside, here remaining is root 2 plus D if I have taken out means what is the remaining? It is nothing but 1 here. So now D will become, D we want, distance we want, where should I place that object? C here. D will become 2 divided by root 2 plus 1. Okay. So 2 divided by root 2 value is 1.41 plus 1. Okay. D will become 2 divided by 1.41 plus 1 means it is 2.41. So 2 divided by 2.41 is nothing but 0.82 meters. So what is the distance I have got? 0.82 meter. That means, so for example, same thing I am consider a mass of A and mass of B. So total distance between them is 2 meter means where I should place this mass of C object means I should place 2 minus 0.82. 2 minus 0.82. So you will get it as 1.18. 1.18 means where should 2 means this is the total distance. 1 means middle we will get exactly in the middle will we get 1 meter. 1.18 means little bit here. So that means I should place an object in distance of 1.18. That is the mass of that object. That is a C object. I should place at a distance of 1.18. Okay, this is the, so this is, this is D we are consider, this is you are considering as 2 minus D. Okay, so 2 minus D, this distance is 1.82 is the distance. 2.2 minus D means 2 minus D is nothing but 0.82, that is 1.18 distance that a object C must be placed so that the gravitational force between the object A and object B is 0. Okay. So I hope everyone have understood this concept. So very important one. So based on this, I have given you the worksheet. Try to do it. If any doubts is there means we will discuss in a live session. Thank you.